So question 11 is a rearranging formula question. It says rearrange, make x the subject. Cx minus 3 is equal to 4x plus d. We got x on both sides. We got cx here and 4x here. So the first thing that we want to do is collect all the x terms to one side and keep all the other terms on the other side. So if we bring cx, bring 4x to the other side, the sign is going to change to minus 4x would be equal to d, and here we got minus 3 is going to come over to the other side and become plus 3. Now cx minus 4x, you got x here and x there, so we can put x outside the bracket and put c minus 4 inside the bracket. Is equal to d plus 3. Now to get rid of, because we don't want the x, we don't want this whole term, we only want x on the left hand side to make it the subject. So we want to get rid of this c minus 4 here. So the way that we can do that is we can divide it by c minus 4, because the bracket there means that it's being multiplied by x, and we're going to use the inverse operation. And whatever we do to this side of the equation, we have to do the same thing to the other side of the equation. So c minus 4. This one will cancel this one, and then we'll have x is equal to d plus 3 over c minus 4. And this is a 3 marks question. So we got question 13 here, which says evaluate, 13b says evaluate 1 out of 27 all raised to the power of negative 2/3. This is negative and fractional powers problem, both combined in one. You have to be careful with this problem because it can look like a really straightforward problem, but it can get really mixed up, so you really do have to be careful about it. If you think of it as if we apply, let's apply this power here to the 1 and the 20, so the numerator and the denominator. Yeah, let's start by doing that. So the first thing that we're going to say is 1 raised to the power of negative 2/3 over 27 raised to the power of negative 2/3 is going to give us what? I'm going to rewrite that using the division sign. 1 raised to the power of negative 2/3 divided by 27 raised to the power of negative 2/3. That would be equal to 1 divided by, I'm going to rewrite this one. If we evaluate this one, this is going to come to 1 or negative 1. Yeah, it's going to come to 1. And then this one is going to, we can rewrite this one as 1 over 27 raised to the power of 2/3, because of course negative power is equal to the inverse, the 1 over the positive power. Yeah, a negative power is equal to 1 over the positive power, so we rewrite that as 1 over the positive power. And if we then do this, we then have a fraction, and when you're dividing fractions, you have to keep the first number as it is and multiply it by the reciprocal of the second fraction. We have to keep the first fraction as it is and then multiply it by the reciprocal of the second fraction. So let's do that. This will be equal to 27 raised to the power of 2/3 over 1. We can ignore that 1 there, okay? And then now it's time to apply this. I think 1 times anything is the thing itself. So let's deal with 27 raised to the power of 2/3 would be equal to applying the laws of indices. We'll have this to be equal to the cube root of 27 all squared, which is equal to 9. And I think that's the answer to that one. So question 14 says, look at the diagram for question 14. That's this one right here. In the separate diagram booklet, the diagram is not drawn to scale. The points A, B, and C lie on the circumference. That's those points A, B, and C lie on the circumference of that circle. Yeah, they lie on the circumference of this circle. The straight lines EBD and ECF are tangents to the circle. EBD and ECF are tangents to that circle. Yeah, you know what tangents are? The line that touches it at a point. Yeah, and angles BEC equals 58 degrees and angle BCA equals 35. So those two angles right there is talking about that one and that one. Find the size of angle ABC. The size of angle ABC. So it's looking for this angle. Something tells me there might be something like an alternate segment there. But how do we get to that one? Because we need to find out what these other angles are. So let's make a start. Yeah. The first thing that we notice here is that angle EBC is equal to angle ECB. Yeah, it's equal to, because you have that tangent there, yeah, touching the circles. Yeah, so that must be equal to that one. Yeah, that line must be definitely equal to that one. And then those angles in that case will be equal, because that would be an isosceles triangle. So therefore, to work out these two angles here, this angle and this angle, we will just use the angles in a triangle equals 180 degrees. So I'm just going to write that as, and put my hand on this side, then you can see better. Angle EBC equals angle ECB, and that equals 180 degrees minus 58 degrees all over 2. I'm going to half it, divided by 2, because I want to split it between this one and this one. Since those two are equal, those two must be the same, and if they are the same, I have to work it up by subtracting 58 from 180 degrees, which is angles in a triangle. Okay, this is going to give me 61 degrees. So here I'm going to have 61 degrees, and here I'm going to have 61 degrees. And my reason is, first of all, two tangents drawn from a point to a circle are equal. Okay, triangle BEC is therefore isosceles, hence angles in a triangle used, okay, to work out those two angles. Now the other thing that you want to work out, now you got these two, yeah, you want to work out what this angle, because something tells me what we're looking for is angle ABC. Yeah, that's the one we are looking for, and that's the one that is in the alternate segment to this one. Now we have these two here, okay, and they are both on that straight line. Yeah, so therefore, to work out what this one is, angle ACF, yeah, angle ACF would be equal to 180 degrees minus 61 minus 35, which is equal to 84 degrees. Angles on a straight line. Okay, so this would be 84 degrees right here. It's right here will be 84, and if that's 84 degrees, then this angle ABC, therefore angle ABC must be equal to 84 degrees, following alternate segment theorem. Okay, and of course, you know what alternate segment theorem is. If you don't know what that is, go look it up in your book, you will know that if you have this segment, this minor segment, and you have this to be equal to 84, then the angle in the alternate segment is the one, the major segment, the angle in that alternate segment must be equal to this one. So this would be 84 degrees as well. So that's the solution to that one. So let's have a look at question 15a, which says simplify the square root of 45. And this is a third problem. And with thirds, you want to be thinking about square numbers. So you want to be thinking about the factors of 45 that include a square number. So what make 45? I think 15 times 3 make 45. Oh, 15 times 3 make 45. Oh, let me use the black one, that's too faint. And also 9 times 5 make 45. Clearly that is a square number because 3 squared is 9. So I'm going to go with that one because that one can be simplified. And of course, you know the rule with thirds. The square root of 45 can be written as the square root of 9 times the square root of 5. And that's going to give us 3 times root 5. So I'm going to go with the first one right there. So next we have question 15b, which is also a third problem, but is asking us to find the square, simplify the answer. Find the square of this this problem right here. So let's evaluate it and then see, we'll get the answer simplified. Okay, the first thing I'm going to do is to rewrite that in expanded form. So 2 root 7 minus root 3 times 2 root 7 minus root 3. And of course, you know how we do expanding brackets. You use the FOIL method. Okay, the first, the outer, the inner, and the last one. Okay, so let's do that multiplication. 2 root 7 times 2 root 7 is going to give us 2 times root 7 times 2 times root 7 is going to give us 2 times 2 is 4. Root 7 times root 7 is 7. That's going to give us 28. So I'm going to put 28 here for the first one done. Then the next one is 2 root 7 times root 3. So that would be 2 times root 7 times root 3. I can't do anything about those two guys. I'm just going to put them in the same root box and leave the 2 outside. So that's going to be minus 2 root 7 times root 3 is 21 minus root 3 times 2 root 21 root 7 root 3 times 2 minus root 3 times 2 root 7 is going to give us the same thing. That's the same thing as the one that we just done now. So that would be minus 2 times root 21 minus root 3 times minus root 3 would give us 3. So plus there. Now 28 plus 3 is equal to 31, and of course minus 2 times minus 2 minus 2 is minus 4 root 21. When we have the same in the roots, we just do the operator on the one that is outside. So the answer to that one will be 31 minus 4 root 21. So this is question 19, and it says write the following expression as a single fraction. It's almost like saying simplify. Simplifying algebraic fractions that involve addition and subtraction. So let's see how we can do this with any type of fraction. The main thing that you want to use to help you is a common denominator. So let's make a common denominator to start off with. So we'll have that to be x times x minus p. Now if we divide this by this fraction, we will use this common denominator to divide this bottom number here. So x times x minus p divided by x minus p, that's just gonna give us x times 1 will be x Okay, and then if we do the same thing for this one, then we will have x times x minus p divided by 1 by x, 1x. That's going to take that x off, and then we'll have minus x minus p. Yeah, and now to simplify this further, we will then have x minus, if we expand that bracket, we will have minus x and plus p over x times x minus p. And then this can cancel this because x minus x is going to go off. We would be left with p over x times x minus p, and that would be the final answer. You'll get the full 2 marks for that question. So question 16 says, ask for the model for question 16, which is this one right here, which is a cylinder. It's not drawn to scale. The cylinder has a base of radius r and a height of r over 6. A sphere has radius r. The value of the sphere is equal to the volume. Oh, can't even read anymore. The volume of the sphere is equal to the volume of the cylinder. Find r, big R, in terms of small r. Give your answer in its simplest form. Okay, so we want to try and work out the volume of this cylinder with respect to the volume of a sphere, and we want to find a way that we can write r. Okay, let's say the volume of the cylinder would be 4 pi big R cubed over 3, which is equal to pi over r, pi r cubed over 6. This is for the sphere and that's for the cylinder. Okay, I want to try and get rid of the fractions first of all. So what I'm going to do is I'm going to cross multiply them. If I cross multiply, I'm going to have 3 pi r cubed is equal to 24 pi the big R cubed. I put it the other way around, but then I can I'm looking for, this is the one that I want to make the subject, so I can get rid of everything else by dividing both sides by 24 pi 24 pi. Yeah, and if I do that, this is going to cancel this, and this right here will become 8. So I can say r cubed, because that's what's left here, r cubed is equal to small r cubed over 8. Yeah. And if I do that, then if I square cube roots both sides, if I cube, because I want to get rid of the cube here, because it says leave your answer in its simplest form, then I can cube root both sides, and that will give me r to be equal to the cube roots of r cubed over 8. Now the cube root of r cubed is equal to r, and the cube root of 8 is equal to 2. So that would be my answer in its simplest form. The big R equals small r over 2. So question 17a says, look at the diagram. Let me expand that. Look at the diagram for question 17a. This is this one. Yeah. In the separate booklet, diagram shows a sketch of the curve y is equal to f of x. The curve is transformed as shown below. So that's the transformation of the curve. Using function notation, complete the equation of a transformed curve. So when I look at those two, let me make that smaller again so that you can see. When I look at those two, I can see that this one has just moved. This graph, yeah, has just been, this is just a slide up. Yeah, it's just a slide up. So it's still going to be f of x, but slide up to 2. Yeah, so that will be f of x plus 2. Yeah. Okay, and then for 17b is the same type of question. For 17b is the same question. You have to this time it says this is f of x, y is equal to f of x. Yeah, so what's this one? Now when I look at this one looks like this same graph, but the inverse is inverted, because you can see everything that is happening on this side here is now happening on the other side, and everything that is happening on this side is now happening on this side. So that would be y is equal to f of minus x. Yeah. So question 18a says a box contains 4 yellow cards and 6 red cards. There 3 cards are chosen at random, one at a time without replacement. Okay, it says without replacement, so that's important. Calculate the probability that the first 2 cards are yellow and the red card and the third card is red. You must show all your workings. People do this in different ways, but I'm going to try and to use a tree diagram to explain this to you, so pay attention. Okay, so if you have the first time it's drawn, you could have a red or a yellow, and the probability of a red would be 6 out of 10. Probability of a yellow would be 4 out of 10, because there are 10 in total, 10 cards in total. Now the second time, the total possibilities would have reduced to 9, so it would be out of 9 this time, because it's removed without replacement. So the one that has been removed, and you only have 9 left. Okay, if a red was chosen here, then you would have 5 left. Okay, but this would still be 4 9s. And if yellow was chosen here, this is red, this is yellow, this is red, this is yellow. Okay, if a yellow was chosen here, you would have 3 out of 9, and then you would have 6 out of 9 left. Okay, you are after yellow probability. You're after the probability. Oops. You are after the probability of getting yellow, yellow, and red. Yeah, so yellow, yellow, and red in the next one. So we should be after this one. If you choose a yellow this time again, then of course it will all be 8s this time, because you've removed 1 and it's not to be replaced, it's without replacement. So this here, yellow here, would be 2 out of 8, and red will still be 6 out of 8. Yeah, so that's the part that we are after. And to get that probability for yellow, yellow, red, we have to multiply this one, and this one. Yeah, so let's do that. Okay, 4 tenths times 3 9ths times 2 8ths. This, oh no, I'm sorry, this is the one that we're after. It's not this one. I was wondering why I was getting 2 8ths. Okay, so that would be 6 8, because we want yellow, yellow, red. Probability of yellow, yellow, red, not that one. Okay, so this one. And 4 times 3 would be 12. 12 times 6 would be 72. 10 times 9 is 90. 90 times 8, 9 times 8, 72. 90 times 8 would be 720. Okay, this looks like 1/10 then. It's 1 out of 10. All right. And to answer the second question, I think the second question says, calculate the probability that at least 1 yellow card is chosen. Probability of at least 1 yellow card. If you extend this now, this would be red and yellow, and this would be red and yellow, and this would be red and yellow. Okay, you do not need to do all of them, at least one yellow. All of these ones here, all of these probabilities have at least one yellow in them. Yeah, the only one that does not have one yellow in it is the one going out there, red, red, red. That's the only one. So that's the one that you need to think about. So we want to have a look at this one, and the last one there. Yeah, and do 1 minus all of that one, because that's the total probability there. I think this would be 4 out of 8. Yeah, so it will be, we'll calculate all of this one, and it will be 1 minus all of that one. Yeah, so probability, yeah, of at least one yellow would be equal to 1 minus probability of red, red, red. Okay, and that's going to give you 1 minus 6/10 times 5/9 times 4/8. And if you did that, that would give you 1 minus 120/720, which is equal to 5/6. Oh, 5/6. And that's the answer to those two problems. That's the first one and the second one. I used a probability tree to help me work out the answer. People do this in so many different ways, yeah? But this is how I've worked it out. And you can use this method because it's quite straightforward. So I think this is like most final question. We're almost at the end. It says solve the following equation. This looks like an easy problem, but it can take you a couple of minutes to get to the end of this problem. So let's make a start. This is an algebraic fraction. So the first thing we want to do is get rid of that 2 there. Okay, so let's say y minus 1 over y times 4y plus 3 is equal to, if we take it to the other side, minus 2/1. Yeah, now we want to try and get rid of that fraction there by cross multiplying. So we're going to multiply this by this and this by this. So then we'll have minus 2 times y times 4y plus 3 is equal to y minus 1. Yeah, and then we'll deal, using big mass, we'll deal with everything that is inside that bracket first. Minus 2 times, we'll have 4 times 4y would be 4y squared plus y times 3 would be 3y is equal to y minus 1. And then we would have, now to expand this bracket, we'll have minus 8y squared for minus 2 times 4y squared minus 6y for minus 2 times 3y is equal to y minus 1. I just want to like rewrite everything to make it easier for myself. So because I want to rearrange it to have y on this side and to make it easier for myself. So I'm going to multiply everything here by minus 1. So that's going to get rid of this negative signs here. Then I'll have 8y times this by minus 1 times minus 1. Sorry, I don't know why I'm just scribbling there. Minus plus 6y is equal to minus y plus 1. Yeah, and now I can take y to this side, take minus y and 1 to this side. I'll have 8y plus 6y plus y minus 1 is equal to 0. Ooh, I'm dropping my squares. Yeah, then we'll have 8y squared, 6y plus 1y will be plus 7y minus 1 is equal to 0. Now we have a quadratic equation. So we can use the formula, yeah. And if we use the formula, A would be equal to 8, B would be equal to 7, and C would be equal to -1. And we remember that X or Y in this case would be equal to minus B plus or minus the square root of B squared minus 4AC all over 2 times A. Now let's substitute. Y is equal to, let me change that to Y now. Y is equal to -7 minus B minus 7 plus or minus the square root of 7 squared minus 4 times 8 times -1 all over 2 times 8. Come back up here to make use of the space up here. Now we can keep on simplifying that until we get to the answers that we're looking for. If it's quadratic, we're likely to have 2 answers or 1 answer. So let's see. Y is equal to -7 plus or minus the square root of 7 squared is 49. 49 minus 4 times 8 is 32 times -1 is -32. -32 over 16 for 2 times 8. We can simplify that further to -7 is equal to -7 plus or minus the square root of 49 plus 32 would give us I think that's 81 or so. This would be Y equals -7 plus or minus the square root of 81 over 16. Now you have Y is equal to -7 plus 9 over 16, or Y is equal to -7 minus 9 over 16. And that will bring us to -7 plus 9 is 2 over 16, or -16 over 16. This will simplify to 1 over 8, or so Y is equal to 1 over 8 or -1, and that will be your final answer. It's a bit lengthy, but you can definitely do it for sure. Just have to go step by step and be patient.